shapes.
Good. Yeah, that's excellent. That's exactly right. Listen.
10 points.
Listen. Form is function. Form is function. What do I mean by that statement? Form is function. This isn't just a chemistry principle. This is a design principle. If I make a knife that's shaped like this,
Maybe.
would this be a good knife? Why not? This is a poor knife.
Sharp. It's not sharp.
Right? Not getting
Well,
anywhere, right? No matter what I do, it's ineffective because it's the wrong shape. Form is function. This will not function as a knife, right? How would this do as a boomerang? Probably not very well. What about as an airplane? Oh, not very well. So, why? Why is that a bad boomerang and a bad airplane?
Because it's not built for those activities.
It's the wrong shape. It's the wrong form, right? It's to build something really is, even on a big scale, on a human scale, we understand that if you want to build something, it has to be made from the right materials that have the right properties and be the right shape, right? Which also means if I made something that was the perfect shape to be a knife, but it was made of rubber, it would still be a pretty
Shape.
True. It'd be a poor knife, right? It wouldn't do a very good job. So, when we go to build molecular machinery, when we want to build a living thing that can do stuff, that can walk around and talk and have thoughts and whatever, make donuts, they have to be doing jobs. And to do a job, things have to be the right structure. They have to be the right shape. They have to have the right form to perform the proper function. So all of the machinery inside the cell is going to be built in big, complex 3D shapes. Does that make sense? What's up, right? This is key stuff. You don't want to miss these ones, all right? If you miss this, you're going to be behind for 3 whole units. Trust me. Not something you want. So with that in mind, we need to start then looking at how we can put together carbon into more complicated shapes. And we start with the simplest of these more complicated shapes, which is the simplest thing we could do is we could start tacking them together and building a chain. Yes? So, if we do that, the even simplest version of that is to make a chain and to not do anything fancy. No double bonds, no triple bonds, no oxygens, no nitrogens, nothing like that. Just a straight chain of carbon. And that straight chain of carbon with nothing but single bonds, we call these alkanes. And you're going to notice that that shows up because in the naming, you'll see that all of these names end in ane, right? So a single carbon is a methane. A chain of 2 carbons is an ethane. 3 is? 4 is? And after that, they start to get logical. 5 is? 6 is? 7 is? You guys would be a terrible kindergarten class. You're bad at this. Come on, all together now. All together now. 8 is?
Octane.
Still bad. 9 is?
Non-ane.
Worse somehow. Last chance. 10 is?
Decade.
You've got this. The rest of you guys suck. But you're good. Yeah, I appreciate it for kindergarten. I support that. And we said we can draw those. So that's the most basic thing. We can build a chain. And that may seem like not very exciting, but actually, interestingly, most of the big 3-dimensional proteins in your body are actually chains that fold in on themselves. So chains become very powerful. We think of a chain as being something that just kind of dangles, right? But you could imagine almost like if you tie knots and things like that, you can make very interesting things out of a single chain. You're going to discover, if you take grade 12 biology, which I hope you do, because it's a wonderful course, though a challenging course. Do you not think so? I thought 4U Bio was challenging. I think 4U Bio is the hardest of the 4U sciences. Yeah. Anyway, that a chain folded on itself can turn into all kinds of very impressive shapes that can do all sorts of impressive things. So, that's the basic. Now, we can have branches. And if we have a branch, we just use the same naming. We just say that it's a blank ill group. So you could have a hexane with a methyl group and an ethyl group. And what that means is that you've got a main chain that is hex, so that's 6. and it would have a branch that's 1 carbon long and a branch that's 2 carbons long. So if you actually look at it, the naming's pretty good. It makes sense. And then I got these numbers in here. This isn't just a ethyl-methyl-hexane. It's a 4-ethyl 2-methyl-hexane. What do those names mean? Why is there a 4 and a 2 there? Yeah. Good. They tell you on the main chain, put the ethyl on carbon number 4 and put the methyl on carbon number 2. Good. Why did they do ethyl and methyl why not 2-methyl-4-ethyl-hexane? What's the rule there? Alphabetical. Good. We put substituent chains in alphabetical order. Yeah. We'll talk about that. So, the question's a good one. On this one, we started counting from the right. But on this one up here, we started counting from the left. How do we decide which side we should start counting from, as a rule?
Whichever side has more of the
substituent? Yeah. That's a brutal word. Substituents. Yeah, basically, you want to start on the side that's closer to the chains, to the branches. So if you look here, the first branch is on carbon 2. That's a better place to start than here, where the first branch would be on carbon 3. So it's not wrong if you do it the other way, but it's not the best. It's not ideal. So at first, you'll probably screw that up sometimes, and eventually you start to get it right with practice. The good thing is, even if you get it wrong, quote unquote, it's possible to get the not best answer that's still correct. In other words, that still correctly defines what to make. And then I would say that's correct, but it's not the best solution. So did that answer your question? All right. So we looked here and we said that in this example, we have 3-ethyl-4-methylhexane. And we said there could be 2 on the same. This is a 4-ethyl 3,3-dimethyl. By the way, if there's a di or a tri or anything, that's not what we base the alphabetical on. The alphabetical would still be based on the fact that this is a methyl group. So becoming a dimethyl doesn't put it in front of ethyl. We put them in alphabetical by ethyl, methyl, propyl, butyl, pentyl, whatever. Yeah? Yes, yeah. Yes, you may. No, why are you sorry? Don't be sorry. I'm not sorry. Thank you. There you go. If you need any clarification, just let me know. Are you okay? I'm noisy. You're fine? Okay. Because I don't know if you know this about me. I'm noisy. Yeah. No, I kind of like it. It makes me happy. Do I have to? I will if you want me to. Would you like me to?
I mean, if it makes you feel better.
No, I just...
Like, why is it like
It's just hard to look at.
one of them is like not Mr. Fernando, and I don't know why did he write it like that, or maybe
Okay,
you're
we'll
trying
get...
with
Oh,
your
okay,
left hand.
No, that's my wrong hand.
I could not
You're like,
tell.
if you're trying with your left hand, maybe you recently suffered brain damage. I don't know. I couldn't really tell. Sorry. Anyway, I shouldn't have said that. I apologize. That was a joke, but it wasn't very... I mean, it was funny, but it wasn't kind.
I
And I like
spent
to
a
be
minute,
kind.
like, figuring out, is there any difference between those two? Like,
I think that's better than I can do with my left hand.
Oh.
Yeah, that's not going well.
Is that a G?
But you use like the tablet too for support with your right.
Yeah, that's true. That 4 looked disturbingly swastika-like. Anyway, we'll move on. It was not good. It was not. We're not. No left-hand writing here. All right, we're not doing that. Anyway, okay. Now, that's the basic premise. Then we can have chains and we can put branches on them. Cool. All right. But as somebody asked yesterday, couldn't you just make a double bond? And could you make a double bond if you want to between 2 carbons? Yeah, of course, because how many bonds does carbon want to make? 4. So if you remember from here, we said alkanes have what hybridization state?
SP3.
Yeah, alkanes are always sp3 hybridized. And their bond angles are always what? Very good. Which is why we draw them usually just like this, but the actual more accurate drawing is that skeleton drawing. By the way, if we were to do this one as a skeleton drawing, right, which is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, right? Because again, we're not counting lines. This here isn't 2 carbons. This is 3 carbons. 1, 2, 3, 4, 5, 6, 7. And then I would never start counting from the right if I'm drawing it. So it says on carbon 4, what am I putting? Ethyl group. So I'll go carbon 1, carbon 2, carbon 3, carbon 4, and I'm going to go up. That would be 1 more carbon, so that would be a methyl group. To make it an ethyl group, I need 2 carbons. Can we all see that? So this would now be 4-ethyl heptane. But then this also says on carbon 3 and on carbon 3, we're going to put 2 methyl groups. So I'd go carbon 1, carbon 2, and on carbon 3, we'd put a methyl group and a methyl group. So if you're going to do this as a skeleton drawing, that's what it would look like. Yep, that's fine. This could be rotated, right? You just flip it. I like to count left to right, right? For some reason, they drew this one right to left. That to me is silly. So I will rarely give you, like this, they're trying to prove a point to remind you that you have to check to count both ways, and that's fine. But if you're drawing it yourself, why would you count backwards? You know, I mean, if you want to, don't let me stop you. You can go up and down if you want. Like if you wanted to, could you do this? I guess, if you're psycho, if you're a sociopath, but I'm not interested. We'll get some practice with this, but that's weird at first, right? Can we all agree that's a little weird? But just remember, we would still draw, if one of these had a chlorine coming off of it, we'd just draw a chlorine like that. So you were drawing bonds, but if we don't bother drawing anything at the end of the bond, then the assumption is that it is a carbon, and then we don't even draw the bonds to hydrogen. We just ignore hydrogen completely. Now, having said that, how many hydrogens are on this carbon? Good. What about this one?
2.
What about this one?
0.
Correct. Very good. What about, oh, golly. What about this one here? No, how many hydrogens on this carbon?
Oh, yeah, 3.
3. What about this one?
3.
What about this one?
1.
This one?
2.
This one?
2.
This one?
3.
Good. This one?
2.
This one?
3.
Excellent. Does that make sense? So, and I also think it even looks better just with the dots, but they don't do the dots. They just do the lines. I don't make the rules.
Do the dots mean something else?
Dots don't mean anything. I just used them there to show you which one we were talking about. But I do think it actually is clearer with the dots. I think it's like, but that's not how they do it. They just go 1, 2, 3, 4, 5, 6, 7. And they say on carbon 3, we'll put 2 methyl groups. And on carbon 4, we'll put an ethyl group. And there it is. So you can see it is agreeably quick, right? See how quickly I drew that as opposed to having to go C, 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 right? You can see why we do it. It also more accurately represents the angles, right? We're not drawing it at 90. Any questions about alkanes? How's that feel? Before we move on, let me draw one. I'm going to do 2 questions. You can do this in the margin. You can do this on a piece of scrap paper. All right, ready? First, I want you to draw 2,5 dimethyl 4-propyl nonane. I want you to draw that for me. 2,5-dimethyl 4-propyl nonane. And then I want you to name this drawing. Just on a piece of scrap paper, piece of line paper, whatever. We just want to make sure we're on the right track here. I don't care. However you want. I want you to draw this for me, and I want you to name this guy. There we go. Okay, now name it. There we go. Right. And if you do,
There is a good reason. Is it tastes good?
oh yeah.
That reminded me of like, you know when before movies had like sound, they would just have like the pictures.
Title cards? Yeah.
Yeah, that's what it reminded me.
Made a silent movie for Eastdale once. Little song I wrote for you. You're welcome. If it helps, I'll help you count here. Again, having told you that I'd count from the left, I made sure to make one where we actually want to count from the left. So obviously you do have to watch out. That might make more sense. Hello? How are you? Certainly you may, yeah. Just want to grab a seat there. You can throw some music on headphones or if you want or whatever to avoid being distracted by my loud, brash voice. There you go. Should be everything you need right there. So if we're naming this, what's our main chain? For the bottom one, yeah. What's our main chain? Okay. You want your numbers to be the lowest. So here, if I start counting here, my lowest number will be a 2, and my highest number will be a, okay? Whereas if I count on the other side, my lowest number will be a 4, and my highest number would be a 9. So, in general, the lowest overall numbers will win. Now, there will be times with other things where a certain thing has to get the lowest number. So you were thinking, oh, shouldn't we get the ethyl group to have the lowest number it could? That's good thinking. As it happens, any branch is kind of treated with equal priority. If it would be the same, if going from the left would give you a 2-methyl and going from the right would give you a 2-ethyl, then you'd be right. Then we'd give priority to the low alphabetic one. So that's a pretty edge case. But generally speaking, lower overall numbers, better. Did that answer your question? It was a good question. So our main chain is how long? So it's called we have a decane. Okay, so we have a decane. And then what's on that decane? 3 methyl groups. So that will be a trimethyl. And specifically, it will be a 2,4,5 trimethyl. Okay. And then what else is there? 7-ethyl. Okay. So all day we have, which one should I put first? The ethyl or the methyl? Okay. So this would be a 7-ethyl 2,4,5 trimethyl decane. Good. Awesome. And do you see that process? How we figure out what the main chain is, we figure out the substituents are. We do the same thing in reverse when we go to draw it. What's the main chain here? Yeah, nonane. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, we're not counting lines. The lines are the bonds. So we're counting vertices. So that's the nonane. Then what do I need to put on there? Good. So on carbon 1, nothing. On carbon 2, a methyl group. 3, nothing. 4, nothing so far. 5, a methyl group. Now this is 2,5-dimethyl nonane. But I still need to add 2,5-dimethyl for propyl. So 1, 2, 3, 4. This is where it's coming off. And what's a propyl group? 3. So 1, 2, 3. Does that make sense? How's that feel? Not too bad? Again, if you wanted to draw this as carbon, 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 go nuts. Nothing wrong with that. But can you see why we invented the skeleton diagram? Like, just because these get big really quickly. If for now you want to kind of imagine them with carbon atoms here to at least help you sort of visualize it, I don't think that's unwise. They don't actually include those in proper diagrams, but I think it's helpful for kind of visualizing it first. And then keep in mind, everywhere we haven't drawn a bond will be a hydrogen, because every carbon will make how many bonds? 4. So there'd be 3 hydrogens here. How many here? How many hydrogens here? 2 is correct. What about here?
2.
Good. What about here?
2.
Great. What about here? 1. Good. What about here? I think we get the idea. 3 is correct. Yeah. Exactly. Yep. Exactly right. Yep, because a dimethyl or a trimethyl doesn't necessarily come off the same carbon. It doesn't necessarily come off a different carbon, so we need to be very specific. And again, this is not in the database probably, but all the same, if I went to MolView, just giving it the name, it's going to figure out how to draw that. You know what I mean? Like it just because it can interpret the name just like we can. So what was that again? That was a 2, 4, 5 trimethyl, 7 propyl. Oh, give me one. Go. Give me the top. The one we had, the top one. 2,5-dimethyl. 2,5-dimethyl. 4-propyl. Nonane. So if you look, not in the list, right? Like not in the database, not something that somebody has built, but all the same, just draws it, right? And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Notably, this is drawn at with 1 on the right for some reason. Boy, that methyl group there is hard to see, but it's there. Can you see that? I hate how that's drawn, right? But it's there. So on 2 we have a methyl group, on 4 we have 5 we have a methyl group, and on 4 we have that propyl group, and you can see it here. And again, you can see that it's actually, it can be kind of sneaky, right? Like this one's kind of hiding on you because it has that kind of zigzaggy shape, because the bond angle isn't 90 degrees. 109.5 is correct. Yeah. What do we call that arrangement again? Tetrahedral. That's right. Yeah.
Is there like an actual way to like orient them? Because like on that one, it drew both methyls like pointing up, but like I did mine pointing up.
Yeah. So the long and the short of it is, don't worry about it. There's something called steric hindrance. There's a whole bunch of things that are going to influence which way these rotate. Sigma bonds can actually freely rotate. So each of these carbons can actually rotate in spot. And it will find the most stable configuration based on the interaction of whatever's there, which in this case is all hydrogens. So yes, there are ways to predict how they'll line up. If you look, the hydrogens are always offset each other. You don't need to know this, but if you look, like that hydrogen isn't going to be directly behind this hydrogen. They're going to be offset from each other, so they're as far away from each other as they can be. Does that make sense? You don't have to know that. Like that's a more advanced organic chemistry, but that is one confirmation. There's nothing stopping this from rotating, so that hydrogen's directly in front of that one, but that's not what happens because they want to maximize the distance from each other. So you can predict. It's an excellent question. You absolutely can predict how they're arranged. I'm not going to make you predict how they're arranged. No, but it can be predicted. There are certain cases where I'm going to make you predict, because some bonds don't freely rotate. We'll talk about that. But for the bonds that freely rotate, you can just say, well, they could be kind of in any configuration. But there is a consistent best configuration. That was a good question. Yeah.
Sorry to interrupt your lesson, but do you want to do the screen period 3?
Yeah, I'll try to get down there. And I'll come to you guys. And if I can't, I'll try to get down there 4th, whatever's going on. And if I can't then, I'll do it after school. that cool? All right. Okay, questions about that before we move on? Because now we're going to say, okay, that's with nothing interesting going on. Just pure sp3, pure sigma bonds, carbon. Okay, but there's nothing stopping carbon from bonding to carbon. In other words, there's nothing stopping us from forming a double bond, right? So, having learned all about sp2 hybridization last unit, you are no doubt screaming, what about pi bonds right now on the inside? Because, of course, you'd never interrupt me in class. Well, long story short, they can, all caps, they can and do happen. And they require us to modify our naming. So ethane becomes ethene. So you remember ethane, we'll draw it over here just to remind ourselves, where we have a carbon, which will make 4 bonds, bound to a carbon that also makes 4 bonds, and of course the remaining bonds are all made to hydrogen, the most abundant atom in the universe, that one bond making cap of organic compounds, that's ethane. But we can compare it, the tail of the tape as it were, to carbon making a double bond to carbon. Now, what will the bond angle be now? What hybridization state is this?
Wouldn't it be like 107?
Nope. 120, because what's our hybridization state now? If we're making one pi bond,
sp2.
very good. So that's an sp2 bond now, which means we're now making this 120 degree bond angle there, which I haven't drawn perfectly accurately, but that's semi-close, right? And so this would be up here, and that would be down there. And of course, there's no longer 6 hydrogens, because with 2 bonds there, each carbon only has to make 2 more bonds. This, and that shouldn't be uppercase, these aren't people. That's not like my cousin ethane, it's a thing. It's like ruler. This is not ethane, this is ethene. All right? So the ane ending tells you all sigma bonds. The ene ending tells you there's a pi bond present. Now, in ethene, there's only one place to put it, right? Bless you. If we have ethane and then we say now make ethene, there's only one way to make ethene, which is to put the pi bond between the 2 carbons. Will that always be the case, that there's only one place to put it?
Yes.
What if we had a 20 carbon chain? Where's the pi bond go? So what if I said make dodecene?
It would be between the carbons.
It's going to be between carbons. Do they all have double bonds? Do they have to all have double bonds? They could, I guess. But could just one of them have a double bond?
Yeah.
So we're going to have to indicate that, right? Our naming is going to have to reflect not only that there's a double bond, but where there's a double bond. All right. So that's not so bad, is it? It makes sense, right? So what we do is, for longer ones, here are 3 different examples. I don't love any of these, but that's okay. These shouldn't have been my examples. But this is what? What's the primary chain here?
Hexene.
Yeah, it's a hex. If it didn't have the double bond, we would just call it hexane. But we need to call it hexene because there's a pi bond present, right? So that pi bond is going to make this an ene, but we need to say where it is. And this pi bond starts on which carbon? Carbon 1. So we would call this hex 1 ene. When I was in school, we used to call this 1 hexene, but they've changed the naming, and I like the new naming better. This is better. It just goes right in front of it. This is hex 1 ene. It's a hex. How long's the chain?
6.
Hex. Great. On carbon 1, what do we need to put? Ene, which means a pi bond, a double bond. Good. That's not bad, right? That's pretty logical. Make 6 carbon chain, and then on the first carbon, put a double bond. And obviously, if it says carbon 1, it's going to go from carbon 1 to carbon 2, right? So they don't say 1, 2 ene. They don't say like between it. They just tell you where it starts. the lower number that it starts at. Yeah. Well, let's talk about it. So now here we have a primary chain that is how long? Okay, so it's a hex, right? But it's not going to be hexane because we have here, it's going to be hex 1-ene. And then what does this have? It has a 4-methyl group. So if we put that all together, what should the name of this be? Very good. Very good. 4-methyl hex 1-ene. Name makes perfect sense. And again, just to show you, this almost certainly won't be in the database at MoleView, right? Unless somebody's been studying 4-methyl hex 1-ene. But if I just type it in, 4-methyl hex 1-ene, let's see, is it in the database? Oh, this actually is in the database. Fair enough, it's reasonably common, right? But if we look, 4-methyl hex 1-ene, and it's exactly what we drew there. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Between 1 and 2, there's a pi bond, and on carbon 4, there is a... Great, and see how that double bond changes the bond angle?
It makes it flat.
It goes flat, which makes sense because what do we know about sp2? It's two-dimensional, it lies flat. So if you do alternating pi bonds, you get a flat molecule. It no longer sits going all zigzaggy like. Sits flat. This one kind of looks like, that sort of looks like a dog with another dog growing out of its head. Can you see it? Dog, second dog, attached via its head. Yeah. It's like a David Lynch movie. Anyway, did you say who? What? I was going to say, I don't think there's 4 David Lynch movies I could show at a high school film club. But do I have to do David Lynch month? Oh my God.
What is it like human
You
centipede?
can show Eraserhead. You can do Eraserhead.
I can show Eraserhead. And what's his boring one?
Straight story, don't call it one.
Okay, I love it. I love Straight Story. Big fan. It's just a normal movie. Elephant Man's a normal movie. It's pretty good. It's fine, but it's like a weepy. It's like an Oscar bait drama. And Dune. There you go. There's a David Lynch month.
That one sucks.
Dune sucks. It's really bad. His Dune is bad. Production design is beautiful. Terrible movie. By the way, I don't know if you noticed, but one of the other things in the database when I started typing this in was 4-methyl hex or 5-methyl hex 2-ene. If I clicked that, let's change that 1 to a 2. If I make this 4-methyl hex 2-ene, what's going to change?
It's going to start from the second carbon.
What's going to start from the second carbon? Very good, the pi bond. Right? Do we see that? That's just how they show it. But there it is. And again, what does that do to the molecule? That whole section, everything associated with anything sp2 lies flat, right? So that whole section of the molecule, because these 2 carbons are sp2, that all lies flat, and we don't get anything coming above the plane until here, where it's sp3, and here, where it's sp3, right? If you made every carbon sp2, the whole thing would lie flat, right? So if you did, we could do that. If we did hex 1, 3, 5 triene, this should all lie flat.
We have to use a prefix as well.
Okay, let's see if we did it. Is this going to lie flat? What's the hybridization state of this carbon? sp2. This one? This one? And? So it should be... That's fun. Isn't that fun? We could make it linear if everything were sp3, right? So if we did 1, 2, 3, 4, 5 pentene, now it should just make a perfect straight line, right? That was a hex, wasn't it? Yeah, why did I change it? This should lie perfectly flat, I think. Why did I say hex there? No, that is what I wanted. It doesn't like that. Oh, that's because it's pent. There's 5 of them. Yeah, look at that. Eh? Whoa. Whoa. It did decide to draw the carbons this time. Isn't that interesting? Probably because it doesn't trust you to realize that those are lines meeting. Isn't that a goofy looking molecule? But point being, see how we could predict the shape before we built it? Because we know our hybridization states. Because now the hybridization state of this is sp3, so it sits flat. It gives us little goofy Mickey Mouse ears. But sp2. The hybridization state of this one, just sp, right? Because it's making 2 pi bonds. sp, sp, sp. So they're just 180. Okay. Now, I want you to take a minute and draw these, and you'll note that just like I showed you there, same rules apply. Diene has 2 double bonds, right? Should go without saying that a triene would have 3 double bonds, right? I'll say 3 pi bonds. That's a lot easier. And actually, they don't necessarily have. And then a triene. I should say double. Actually, it's more accurate because they have to be double bonds to be enes. A tetrene. Tetrene has 4 double bonds, etc. Everyone knows tetra is the prefix for 4. It does, doesn't it? Because like tri. Yeah. But like Tetris is all the made of all the possible arrangements of 4 little blocks, right? So that's one arrangement.
But isn't a tetrahedron like a pyramid?
But it's four vertices, right?
No, but it's a triangle.
It makes a triangle, but there's 4 vertices, right? Which is weird. It is weird. Like, it's confusing. I was like way older than I ought to have been when I realized that Tetris just meant all the arrangements of 4 blocks. Do you ever discover something older than everyone else? Like when you were older than everyone else, you learned something that everyone else has known since they were a kid? Like, I don't know if you guys, there was a show called The Polka Dot Door. You don't know The Polka Dot Door. But there was a show called The Polka Dot Door. It was a kid's show. It's pretty great. It's pretty entertaining. And then there was this recurring character called Pokeroo. He was a big kangaroo. And he'd come in. And then Pokeroo would always come in, and there was this one guy who always like missed Pokeroo. He never saw him. And then he'd come back after Pokeroo had left, and he'd be like, I missed him again. And I was like 32 before I realized, that's Pokeroo. He's the guy who goes in the costume. Yeah, but like as a kid, you were supposed to figure that out and find it funny, and I was like thoroughly an adult before I caught on. Yeah. Yeah. Anyway. All right. Go ahead, draw these, please. Did you have a question today?
No, I'm just
See how you can tell that your idiot science teacher didn't catch on, so he was like, and I think I often caught on because I was telling my kids that, and it was like, he was the Pokeroo, and I was like, I see, it all comes together now. Anyway, I'm the guy who like Superman Clark Kent, like he takes the glass off, and like different guy, can't tell, can't see it.
So much empty. Is that how?
1, 2, 3, 4, 5. Good. And then 1 diene and 2 dienes, and 1 ene and 2 enes, and then 1, 2 dienes. Perfect.
So that's fine. You don't
Literally perfect. Nope, you're good. Well, the way you drew it, right? So, yep. 1, 2, 3, 4, 5, 6, 7. So it's a hapt. Great. 1, 2, 3. 3 ene. Good. 3 ethyl. 1, 2. Yep. 2 methyl. Yep. Beautiful. It's perfect. Do you want to put one up? Yeah, when you got one, go put one up there. Whatever one you want.
I beat you to it.
Why did it make an arrow?
All right, how we doing? Can we take a look at these? So this first one, our primary chain has to be how long? How long is our primary chain here? Yeah, so 1, 2, 3, 4, 5, 6. Did we do that? Yeah, looks pretty good to me. We need a 2-ene. Did we accomplish that? Yeah, looks good to me. And then we need 2-methyl. Carbon 1, carbon 2. Put a methyl. Yeah, we got it. And we need more colors than we have. And we need never. 3-ethyl. What do you think this is? History class? Everyone knows history class is for sparkles. English class is for catching up on your sleep. Math class is for fun. Geography is for picking up girls. Science is serious business. I don't make the rules. Those are the rules. Yes. On which one? What are you talking about? Alex, have some confidence, for God's sakes, man. That's perfect to me. How do we feel about that? Is that okay? Does anyone want me to go over that? Okay, that's good. I'm going to redraw it in black down here just because I highlighted that, but that's excellent. Very good. So 1, 2, 3, 4, 5, 6. Double bond there, a methyl group there, an ethyl group there, and we are golden. Well done. Here, a pent. So we know our primary chain is 5. 1, 2, 3, 4, 5. Beautiful. And then it's a diene, which means there's 2 double bonds, and one of them is going to start on carbon 1, and the next one is going to start on carbon 2. Now, watch out that you don't accidentally make something impossible. This one's fine. One year on a final exam, I screwed up, and one of the questions I asked people to draw on the final exam was impossible. Because if I said this and then also said it was a 2-methyl, could you do that? No, right? You can't have a 2-methyl 1,2-diene because that would require this carbon to be making 5 bonds. So it's always not a bad idea to quickly check and just make sure there's no carbons that are making more bonds than they can make. That wouldn't be your fault, by the way. That would just be a bad question. But you do have to watch out. You can't make, just because you can name it doesn't mean you can build it, right? You can't break the rules. Can't break the rules, yeah. That's fine. Totally fine. Don't worry about it. There are some rules about how bonds get drawn, like you saw the crazy cross bond like that in the one example. We'll talk about that. You don't need to worry about it for now. We'll get there. You don't need to worry about it for now. Okay, here our primary chain is hept. So 1, 2, 3, 4, 5, 6, 7. Beautiful. It's a 3-ene, which means on carbon 1, 2, 3, there should be a double bond. There is. Awesome. Should be a 2-methyl. Yep. And a 3-ethyl. Yeah, that's golden. Well done. How's that feeling? Not too bad? Does it feel okay? Awesome. Now, if something can have double bonds, carbon can also have triple bonds. And hence, my clever witticism in my title, triple bonds are named alkynes. Hence why this lesson is alkynes of, oh God, just shoot me now. So anyway, it's all kinds of fun. Yeah. Okay. Last night, Calford and I were presenting at a math conference. We gave a presentation on individualized assignments, which I know you all love and appreciate. But afterwards we went out for dinner. But do you remember Mr. Petch? He came out and joined us, so it was nice to see. Were you about to say it? Because I will throw something at you. Were you about to say it? Say no. Tell me no. Tell me you weren't. You weren't. Okay, good. Anyway, so being at a dinner table was delightful, obviously, but being at a dinner table with all the punniness of Calford and Petch, I was reminded that this is too much. This is too much. I can't handle puns. And all the smartest people I know are really into puns, so I think it means that I'm stupid that I don't like puns. But boy, I don't like puns. I just don't get it. I don't understand. Because it's like, yes, that word sounds like that other word. That is correct. You know? That's not a joke. That's just two words that sound the same. You see what I'm saying? I don't get it. I don't get it. Anyway, that's the end of my story. All right, so let's remind ourselves. Recall ethane looks like what? What's ethane? Yep, sure. Absolutely. 100%. So a carbon with 3 hydrogens stuck to another carbon with 3 hydrogens. All the bonds are single bonds. That's ethane. Then we remember ethene looks like what? Double bond between them. Why don't I have to call this F1ene? Yeah, it wouldn't be wrong, but it wouldn't be the best name because it's unnecessary. We don't need to say that the double bond's on 1 because there's nowhere else to put it. So you wouldn't be incorrect if you said F1ene, but everyone would make fun of you. They'd like...
So if there is a long chain and the methane is on the first one, the methyl thing, so would we do like 1 methyl propane?
You can never have a 1-methyl. There's no such thing. Because if it's a 1-methyl, it just means that there's an extra carbon on the end, which just means the main chain is 1 longer. Do you know what I mean? You can't have a 1-methyl. You could have a 2-methyl. But think of it this way. Like right now. Okay, ready? If I make this, don't draw this. If I make this 1-methyl ethane, well, it's not ethane anymore. What is it? Just propane. Does that make sense? So you can't have a 1-methyl because if you put it on the first carbon, it just becomes the first carbon and the chain is longer. Did that answer your question? Sorry. All right. So now ethine, which tells us that we have a double bond, or not a double bond, a triple bond. Thank you. Sorry. Would look like this. Carbon, triple bonded to another carbon. What's the hybridization state now? Which means the angles are going to be 180, which means where should I draw the hydrogens? Like this? Straight lines. Very good. So ethine should look like that. Apropos of nothing, could we draw the electron configuration for that carbon? Right? It would have a full 1s. And then what would its second shell look like? What would its valence shell look like? 2sp. How many orbitals is that? 2. And then what else? And how many there?
2.
Great. And what's in them all? Does it have any lone pairs?
No.
So sigma bond, pi bond, pi bond. Good. Very good. Don't forget this stuff. Just draw a new unit. Doesn't mean you forget the old stuff. Is it helpful if I do this once in a while? Just remind us of days gone by. And that bond angle is 180 degrees. And that makes this a linear molecule. If I go to MolView and I look up ethine, I'm going to get a linear molecule. Isn't that a goofy-looking Lewis structure, or skeleton structure? But there it is. And there's the molecule, just like we drew it, in all its glory. Polar or nonpolar ethine? Has to be nonpolar, right? Even if the bonds are polar, it doesn't matter because it's linear. Carbon-hydrogen bonds aren't very polar anyway, so it'd be nonpolar one way or the other. There you go. Now, of course, a triple bond can be on a longer chain as well, in which case we, of course, need to locate it, right? So here, which side should I start numbering this one from? Yeah, so we'd call this carbon 1, that carbon 2, that carbon 3, that carbon 4, that carbon 5, that carbon 6. So what's the primary chain here? Okay, so it'd be a hexane, except it's got there, so it's a hex 2 ine. Very good. Hex 2 ine. Sure, diine. Now again, This one couldn't also be making a triple bond, obviously, but could we put a triple bond here if we want to and just lose the hydrogens? Sure, absolutely. And what you'll see is we could also have a structure where there's a triple bond and a double bond. That's annoying, but that's okay. What is the primary chain here? How long? Okay, so that's a pentane, right? Only it's not going to be a pentane because this tells us that actually it's going to be this tells us it's going to be a pent 1-ine, right? But this tells us it's going to be a pent 1, 2, 3 ene. So what do you do with that? Pentenine? Yeah. Yes, correct. So we would call this pent. And then we do these in alphabetical order as well. So we'd say pent 3 ene. But because we're not done, we're not going to end on that E. All right? We don't get the final E till the end of the name. So pent 3 ene. Keep going for me. 1 ine. And we never put the final E till the very end. So it's not, but that's still pronounced ene, not N. Does that make sense? That's the name. Pent 3 ene 1 ine. Stupid name. That'd be a terrible name for your dog. Well, kind of cute. And if we look here, what was that? Pent 3 ene 1 ine? Is that right? There it is. Right? And note, this molecule is perfectly flat until you get to that last carbon, because that last carbon is the only one that's sp3 hybridized. Right? And if you look, on carbon 1, we have a triple bond. That's the 1 ine. And on carbon 3, we have a double bond. That's the 3 ene. And there's 1, 2, 3, 4, 5 carbons total. And of course, there's 1 hydrogen on the first one, because carbon makes a total of. There's no hydrogen on the second. There's only 1 hydrogen on the third, 1 hydrogen on the fourth, and then the fifth has 3 hydrogens. Yeah. This kind of looks like a poodle. Does it?
Like rotate it on its.
Like that?
Yeah.
I guess.
See it?
Kinda. I don't like guns. I'm not a gun guy. The thing about a gun is like,
It shoots people.
yeah, no, like, yes, true. And like, but it's just like, it doesn't do anything else. You know, like a knife, you can obviously hurt people, but you can also cut cake, right? Or you can like, right? And I like cake. Or you could cut vegetables. Or you could do art, right? Right? A gun, it's kind of like, it's kind of got one job. You know, it's kind of got one job, and that job is killing stuff. I don't, and like, I have family who are hunters. I'm not a hunter. I don't get it. But like, I have no problem with that. So like, I get a hunting gun. Like I get like a gun you hunt with. But then you think like handguns. Nobody's hunting with a handgun, right? That's just for shooting people. And I'm going to give you a hot take right now. I don't think we should shoot people. That's what I think. I just think we shouldn't do it. I think, you know what? If you came to me and said, hey, Orlando, I was thinking about shooting Kardik, I'd be like, me too, but we shouldn't do it. We shouldn't do it. We shouldn't do that. We shouldn't shoot Kardik. You don't shoot people. And then Kardik could come up to me and be like, hey, I heard Crichton was thinking of shooting me. I was thinking of shooting him first. And I'd be like, I don't think you should do that either. I just think people shouldn't shoot people. This is my hot take. And so then I think, here's the thing I don't get. If there's a thing we should never do, shoot people, why have a thing that's only job is to do that? Do you know what I mean? It would be like you had a car and it could only speed. Like all it could do was 300 kilometers an hour. Like you press the pedal and just boom, you're speeding. They wouldn't let you make that, right? That wouldn't make sense. Because why build something that can only do something you're not allowed to do? You know what I'm saying? Right? I don't get what, and I get like you can shoot targets or whatever, but like hell, half the time the target is like a drawing of a person, right? Like here, this is a person. And you're like, well, that's a mixed message, right? Right. So anyway, having said that, I don't know anything. What do I know? I'm just saying I don't like guns. So then I was always like, I'm not going to let my kids have guns. We're not going to do that thing because I don't like them, right? And I discovered something, which is, boy, kids will turn anything into a gun. They find a stick. You know what that stick is? Man, it's a gun. And then you take the stick away. You know what they discover they have? Hands. And now that's a gun. It's just a losing battle. It was a losing. See, but see, this is antisocial. You're pretending to shoot me. I had a high school teacher who used to do that. He would go, Mr. Pentland, grade 10 science. And he'd go, Orlando, atomic weight of boron. And exactly, I'd react just like that. And then he'd do this. He'd go, Sam, thoughts? And then you'd be like, oh my God. And he'd literally just go through the class pretending to shoot you until somebody got it right. That's weird, right? That's weird. I didn't like it. Anyway, yes.
Oh, yeah. Crazy thing, some guns can bring people back to life. If you like use a taser gun on somebody who's like,
If I had
yes. Think about it.
if I had a taser right now, I would jab myself with it so hard rather than listen to this. Anyway, can we move on? I'd just feel like, you know what? I had a good run. Anyway, would you like that sound effect again? A little bit of that. Anyway, can we move on? Oh, yeah. Yeah, no, this is good. No, you know what? This is good. No, you know what? I say lots of embarrassing things. But you know what this stream has been? Don't shoot people. That's a good stream. I stand by that one. No. That's the point. That's the way you can deserve a lot of things. You can deserve to be sent to your room without dinner. You can deserve to go to jail. You can deserve, there's lots of things you can deserve. Describe deserving to be don't. For God's sakes, don't. But I'm going to postulate, my premise is, nobody deserves to be shot. That's a thing people don't deserve. No, don't do this. Don't do that. What? He's like, what? Have you met Joe Orlando? Come on.
So many people deserve to be shot.
What?
So many people.
So many.
There's at least 100 people right now who deserve to be shot.
What? Okay, no. Hitler's dead. You can't shoot somebody who's dead. They cremated his body. You can't.
Are you the type of person to go back in time and shoot baby Hitler?
I don't understand what would be wrong with that. What would be wrong with that?
You just asked what would be wrong with shooting a baby. Think about what you just said. Think about it. No, pause. No, hold up. You have the power to go back in time, and your only option is when he's a baby? That's demented.
Teenager. 10 years old.
No, shoot a teenager all day. No, 10? You can't shoot a 10-year-old. No.
A 10-year-old has more worth than the life of 6
No, dude, that's a false dichotomy. Because a 10-year-old, you cannot convict people of crimes they haven't committed for 34 years.
Well, you know what'll happen.
You don't know anything. Like, you can't.
Yeah. If we have a time machine, we low-key do.
Listen, if you have a time machine, be like, hey, Guten Tag, 10-year-old Hitler. You want to go on a fishing trip, and then, I don't know, bring them to the future. Right? Where they all know it.
Don't try.
No, wow, okay. And listen, like, I want to be clear. Anti-gun, also anti-Hitler, anti-both, all right? Two things can be true, right? Two things can be true. A lot of things can be true. I'm anti-Stalin. I'm anti-Mussolini. You pick your dictator of the 20th century. I'm not a fan. I don't know. I would rather see them in prison.
And not dead?
Yeah.
They wouldn't hurt anybody if they were dead.
Wouldn't hurt anybody if they're in prison. They stayed there. Sorry?
This time they can't be put in prison. They're the dictator of the country.
Well, again, they can't be put in prison because they're long dead. But the point being, yeah, I don't know. Anyway, yes.
If I answer all three,
I mark all three. There's no bonus, but your test will be out of more than if you only answer two.
do you need a higher
Nope, absolutely not. Okay. No, if you answer all three, I'll just mark all three. I have the technology, Kate. I'll just mark them all. Kate,
when you
Kate, look at me. Look at me.
take the higher...
No, I will just mark them all. Yeah, no, so your test will just be your test will be out of 3 more than it would have been otherwise.
Oh.
Right? So just the denominator changes and the numerator changes. Now, it's still not a bad idea because if you know the answer, it means that any question you got wrong earlier will be worth less. So it's actually a good deal. If you know it, I'd say do all 3.
Okay.
Yes? On which example? This one here?
Yeah.
That's a good question. Why did I count from the right instead of the left? Yeah.
Because that's like where, that's like the highest number where like something's happening.
Good. If I counted the other way, what would the name of this be?
Hex 40.
Fex, fex, not fex. Hex. Hex. 1, 2, 3, 4 ein, which by the way is the same structure, so it's not wrong, it's just not the best name. Like if we look here, if I tell it to make hex 4 ein, it's going to make the exact same thing as if I tell it to make hex 2 ein. So it's not an incorrect answer, it's a suboptimal answer. Does that make sense? It's not wrong, it's just not the most parsimonious, it's not the most efficient answer.
I thought because it was part of the main chain, it could be either or.
So it can be either or. But the rule of thumb is, in general, we want to name such that we keep our numbers as low as possible. Yes, Kate Odette?
If I don't finish it, I'm gonna work it.
Oh, sure. Yeah, absolutely. Okay. What would we call this silly fella here? Yep. Is that hand or am I going nuts?
And
Which number, should I start numbering from the left or the right here?
Right.
So this one, I really wouldn't care either way. As a rule of thumb, when they tie, we go for the lower alphabetically. So we would give this number 1. But honestly, if you started from the other side here, I wouldn't care. That's a real... I just said it's okay. Don't settle the... Uh-oh. No uh-oh. What's this called? Pent.
1 and
Yeah, and again, these are both fine. I'm going to give the priority to the een. So pent 1 een, 4 ein, but it doesn't really matter. Okay? And then this silly fella here. He's a decane, but he's not a decane. He's a diene, ein. Have we named this yet?
deck 6, 7,
Dec 6, 7, diene. We still say een, even though, yep.
1, 1, 3,
Ein. Yeah. Yeah, there you go. Dec 6, 7, diene, 1, 3, ein.
I'm so happy to not be dyslexic right now.
You're so happy to be what?
Not dyslexic.
Yeah.
This would kill me, bro.
Yeah, this is rough. But it is logical. Like this naming may be clumsy, but if you think about it, it's really the name is just an instruction on how to build the thing, right? Dec. How long is my main chain? 10. 6, 7, diene. On 6 and 7, add 2 enes, which are double bonds. And on 1 and 3, diene, add 2 eins, which are triple bonds. And that's it. That's all. If we plug this into MoleView, again, I would be shocked if that's in its database. So Dec, what was it again? 6, 7? Diene. And then what was it? 1, 3? 1, 3, diene. You all right? And there's that one. I don't know what that looks like. Does everything just look like a gun to you?
That looks like a snake. It looks like a dog. It has a tail. It's a long tail. Or a cat. It looks like a cat.
For some reason, I'm picturing like one of those insects that has a real like stingy tail.
Scorpion.
Yeah, maybe a scorpion or something scorpion adjacent. I don't know. Because scorpion has like a curvy tail.
Can you get one that looks like a spider?
That could be a good challenge for you. All right. Listen, guys. Whoever can make an organic compound that looks like a spider with a name, that's our challenge. It has to have a proper name. It has to follow the rules. It has to be spider-looking.
You get extra credit.
You get my admiration. What more could you conceivably want? No. No, you do not. But if you're interested.
This is what I meant.
So there's your longest chain here. Because it's not pentane. Your longest chain here is 4. Right?
Right there.
4. That's a chain. A pencil?
So this whole would be the same chain.
That's all one chain right there. Whoa. So how long's that?
Wouldn't it be like
1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a nonane. And then on carbon 1, 2, 3, 4, it's got a.
huh?
That's a 9 carbon
Isn't
chain.
it a straight line and then
Nope, it's longest chain. Now, this is a stupid way to draw this, except it fits in the space, right? If they tried to draw this as 9 straight, it'd be too long.
Oh,
So that's a nonane. Whoop. And then on carbon 1, 2, 3, 4, we have a 4-methyl. And then on 5, 6, on 6, we have a 6-ethyl.
so 6 ethyl 4 methyl.
Beautiful. Does that make sense?
I didn't know about the.
Yeah. So guys, just a reminder, when you're doing your homework, keep in mind that the longest chain can be deceptive. For example, let's look at this fella here, number 6. Where's the longest chain? Is that the longest chain? No, we can actually make a really long chain here. What's the longest chain? Start there. And then, any reason that can't be a chain? And how long is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it's a decane, right? And then that would be a group, that would be a group. So just be mindful, the chain doesn't have to be straight, right? It doesn't have to make a straight line.
What if we don't see that chain and
Then you have failed.
Oh.
Then you've failed. And then nobody will care because it's one mistake and we'll just say like, oh, actually that was a longer chain. And then you should go, oh, cool. But you will go, oh, no, and you'll be all stressed out. But you shouldn't be because it's not a big deal. So that felt more condescending than I meant it to.
means like all the questions I did will be wrong.
No, not all. Not all. This one has a longer chain. This one, that's your best chain, I think. But this one, that's your longest chain. And this one, that's your longest chain. So just a couple. Just a couple. Oh, this one. That's your longest chain. And here, oh, big long chain here. Now, this is a stupid way. This is like tricky for the sake of being tricky. I don't support that. I like to be tricky, but not really just for the sake of being tricky. But that's probably how I'd identify the longest chains there. Anyway, try those. Listen, guys, we want to be real good at this. Because on Monday, we're going to start putting stuff on the chains to make them interesting. Carbon chains are boring. Boring, non-polar, hydrophobic, disinteresting. But we start gussying these things up. We put some oxygens on those, some hydrogen, some fluorine, some chlorine, some bromine, some iodines, some nitrogen, some esters, some ethers, some carboxylic acids, some whatever, phosphates, alcohols, aldehydes, ketones, whatever. Anyway, it's all easy. Organic chemistry is fun. Till university, then it will ruin your life. High school organic chemistry is fun. No! Oh my God, no. To reiterate, organic chemistry, challenging but good. Guns, not a fan. Again, to be clear, like hunters, sure. But like, you know, like if people didn't have guns, then police wouldn't need guns. Police in Japan don't carry guns. Police in England don't carry guns. Except for like the riot squads, and they carry like big machine guns. But point being, you know what I mean? Like if people don't have guns, then the police don't need to have guns. Then we can all just not be shooting each other. And again, like to be clear, you know, like whatever. That's just my opinion. And obviously, some people like guns very much. Some people very much like guns, but I don't get it, and that's okay. That's why they have menus in restaurants, because different people like different things. Some people like the idea of going back in time and killing toddlers, and some of us find that to be some of us find that to be an odd choice. But you know,
Kill them before they're born.
Kill the mother.
kill the mother. But like no, like in all seriousness, joking aside, like you don't actually think that's justifiable.
Yeah.
You think killing Hitler's mother is justifiable?
Okay.
In what world?
Where's the cutoff?
Well, I mean, hell, you just go back and kill the first human, and then we can be sure none of the bad things have happened, right? I mean, I guess that's logical. Hell, if you really want, we can just go back to like the first life that formed on Earth and just get our foot in there and be like, oh, no, right? But like, come on. Like,
You want to live.
oh, you want to live. Okay, got it. Well, for the record, do you think you'd be alive right now if World War II hadn't happened? You certainly wouldn't be alive right now. Of course you wouldn't, right? Like, not to get into the details, but you are one sperm that met one egg. You think if the entirety of 20th century history changed, the timing would work out perfectly? You don't think any events related to World War II changed the timing of the world leading up to your conception? You kill Hitler, you're done. You're out of there. Right? Obviously? Like, obviously.
That means saving 6 million people?
No, but that's fine. But your argument was you want to live. To be clear, you go back and kill baby Hitler, everyone you've ever loved in your lifetime is not here. Right? Obviously. You're wiping them all out. Right? And again, to be clear, like, these are interesting challenges, right? If you could save a massacre that is obviously unjust and horrifying, but the result of that is it prevents the birth of billions of people since, but then you also get the birth of new people who currently don't exist. Is that justifiable?
What if those people are better?
What if they're worse? Thank you. I need a name. Do I have a name?
It's at the top.
Mr. Orlando, you owe me extra credit. I even gave him eyes.
That's pretty good. Send me
Thank
that.
you.
That's pretty
How
good.
do I send you it?
I don't know. Screenshot it and
I got
message
it.
me.
Wow. Can you just do like
Looks like my happy place on that board.
Sorry?
Looks like my happy place on that.
There you go.
Can you do like just do like a benzene with like ethyl branches?